All right, so now we continue with our dehydration of alcohols. You can see I got this one right here. We have this long chain, 1, 2, 3, 4, 5, 6. So this is 3-hexanol. And we're going to treat it with some concentrated sulfuric acid. And so now there are two products that could happen. All right. With something like this, it's going to be tough to figure out because this third carbon could bond to number 4 or number 2, and we get the same number of carbons attached to that double bond. All right. If we jump down here, we get the same product. There is no major product because if we create a double bond here to the bottom one or a double bond here to the top right, we're going to get the same product. And so this is something you could walk through. If you do this, take a picture of it, send it to me, and I'll walk you through if there's any problems. Oxidation of alcohols. This is extremely, extremely, extremely important. All right. We're going to keep talking about this. A double bond is formed to the oxygen atom in the alcohol group. So this chunk, like what you're seeing right here, is important. A primary alcohol turns into an aldehyde, and then you can oxidize it further to a carboxylic acid. That's what your body does. Secondary alcohols, you form a ketone, done. Tertiary alcohols, no reaction happens. So here, this is ethanol. I beat this reaction like a drum because we have to understand what's going on here. All right. So we oxidize it. That's what this bracket with an O is. You get this aldehyde, which is carbon double bond to an oxygen with an H, and you get water off of it. So it's been oxidized. We can further oxidize aldehydes into carboxylic acids. Boom. And we get an O there. So essentially, when you drink ethanol, booze, your body takes this, and through a long series of enzyme catalyzed reaction, you end up making vinegar. Right? Down here, this right here, this is rubbing alcohol. This is a secondary alcohol. All right. If we oxidize a secondary alcohol, a ketone is formed. So if you oxidize rubbing alcohol, you get acetone or nail polish remover. Boom, right there. Here, this is a secondary alcohol. You should get a ketone. Here, you get a primary alcohol. You should eventually get a carboxylic acid. If you run through these, take a picture, send them to me, and I'll walk you through it. Down here, we could start talking about full reactions. So what a breathalyzer does, you can read this. Alcohol is exhaled, and it'll be oxidized by red, orange, potassium dichromate. The dichromate ion becomes this chromate ion, which is green. From here, blood alcohol calculation can be done. So that's how a breathalyzer works. So here, well, here's a couple of problems with alcohol, but here we can fully oxidize ethanol. We get acetic acid. Here, if we fully oxidize methanol, what you get to is you get the formic acid, but before that, you get to formaldehyde. That's problematic. I'm not sure if you took high school biology or not, but that can be a preservative for dead things. So don't drink methanol. Ethers. Ethers is a terrible chemistry joke. Is an oxygen with a carbon on either side. See what I did there? So it's a carbon on both sides. That's what these two R groups are. An epoxide looks like this. All right. And so here, this is moth pheromone. We get an epoxide there. This guy right here, this is hemibrevetoxin B. That's bad for you. That's a neurotoxin. But you could see there's a bunch of ethers in there. All right. We also get like household epoxy. If you epoxy your table, that's what you're dealing with here. You're working these epoxides.